According to the Electrical Code section 680.74, the question of whether a motor needs to be bonded to a copper tub supply valve in a residential dwelling using plastic water piping for the water supply has a straightforward answer: no. The requirement to bond metal parts is typically associated with creating an effective ground fault current path. This path ensures that in the event of a fault, such as a live wire coming into contact with a metal enclosure, the fault current can quickly return to the source, tripping the overcurrent protective device like a circuit breaker or fuse. This rapid clearing of the fault minimizes the risk of electrical shock. In scenarios where plastic water piping is used, the non-conductive nature of the plastic eliminates the possibility of the water piping system becoming energized. Since plastic does not conduct electricity, it cannot serve as a path for fault currents. Consequently, the need to bond the motor to the copper tub supply valve is negated because the purpose of bonding, to provide a low impedance path for fault current, is irrelevant in the absence of a conductive water piping system. However, it is essential to ensure that other metal parts within the vicinity of the motor, which are likely to become energized, are properly bonded. This includes metal enclosures, metal conduit, and any other exposed metal components that could potentially come into contact with a live conductor. The bonding of these metal parts ensures that a person touching them will not be exposed to a dangerous voltage in the event of a fault. It is crucial to understand the specific requirements outlined in the electrical code for bonding and grounding, as these requirements are designed to enhance electrical safety. These requirements often vary based on the specific application, the voltage level, and the presence of other conductive elements in the vicinity. Therefore, it is always advisable to consult the latest edition of the electrical code and to seek guidance from a qualified electrical inspector or engineer to ensure compliance with all applicable regulations. For example, the presence of other metallic systems, such as gas piping or metal ductwork, may necessitate additional bonding measures to maintain overall electrical safety. Furthermore, the type of motor and its application can also influence the bonding requirements. Motors used in certain hazardous locations may require special bonding and grounding provisions to prevent the accumulation of static electricity or the ignition of flammable substances. The electrical code also addresses the bonding of equipment in agricultural buildings, healthcare facilities, and other specialized environments, each with its own unique set of requirements. In addition to bonding, grounding is another critical aspect of electrical safety. Grounding involves connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. A properly grounded electrical system can prevent voltage fluctuations and reduce the risk of electrical shock. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode to the service equipment, providing a low impedance path to ground. It is important to ensure that the grounding electrode system is properly installed and maintained to ensure its effectiveness. The electrical code specifies the size and type of grounding electrode conductor required for different service sizes. Regular inspections of the grounding electrode system can help to identify any signs of corrosion or damage, which could compromise its ability to provide a reliable ground connection. In summary, while the motor does not need to be bonded to the copper tub supply valve when plastic water piping is used, it is crucial to ensure that all other metal parts that are likely to become energized are properly bonded and grounded in accordance with the electrical code. This comprehensive approach to bonding and grounding helps to create a safe electrical environment and protect against the risk of electrical shock. Furthermore, it's imperative to consider that local electrical codes and regulations may have specific amendments or additional requirements that must be adhered to. Always consult with local authorities and qualified electricians to ensure full compliance. It's also worth noting that even though plastic water piping eliminates the need to bond to the water pipe itself, the equipment grounding conductor within the electrical circuit that serves the motor still needs to be properly connected. This equipment grounding conductor provides a path for fault current back to the source in the event of an installation failure within the motor. The size of the equipment grounding conductor is typically determined by the size of the overcurrent protection device protecting the circuit. The purpose of the equipment grounding conductor is to quickly trip the circuit breaker or fuse in the event of a fault, minimizing the risk of electrical shock. Additionally, it is important to differentiate between bonding and grounding. Bonding is the connection of metal parts to create an electrically conductive path, while grounding is the connection of the electrical system to the earth. Both bonding and grounding are essential for electrical safety, but they serve different purposes. Bonding helps to equalize the voltage potential between metal parts, while grounding provides a reference point for voltage and helps to stabilize the system. The electrical code provides detailed requirements for both bonding and grounding, and it is important to understand these requirements to ensure that the electrical system is installed and maintained safely. When working with electrical systems, it is always advisable to follow safe work practices, such as de-energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock or other injuries. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the electrical code. Remember, the electrical code is not just a set of rules, it is a set of guidelines designed to protect people and property from electrical hazards. By following the electrical code, you can help to create a safe electrical environment for yourself and others. Now let's delve into some additional aspects related to bonding and grounding in residential electrical systems. Firstly, it's crucial to understand the concept of the main bonding jumper. The main bonding jumper is a conductor that connects the grounded conductor, typically the neutral, to the equipment grounding conductor, the service equipment. This connection ensures that the neutral and ground are bonded together at one point, creating a lower impedance path for fault current. The size of the main bonding jumper is determined by the size of the service entrance conductors. The electrical code provides tables that specify the minimum size of the main bonding jumper based on the service entrance conductor size. Secondly, let's discuss the importance of supplemental grounding electrodes. While a single grounding electrode is often sufficient, the electrical code may require supplemental grounding electrodes in certain situations. Supplemental grounding electrodes can help to reduce the ground resistance of the grounding system, providing a more effective path for fault current. Supplemental grounding electrodes can be ground rods, ground plates, or other approved grounding electrodes. The electrical code specifies the spacing requirements for supplemental grounding electrodes. They must be installed at least 6 feet apart to ensure that they are electrically independent. Thirdly, it's important to be aware of the requirements for isolated ground receptacles. Isolated ground receptacles are used in sensitive electronic equipment circuits to minimize electrical noise. These receptacles have a separate grounding conductor that is isolated from the building's normal grounding system. The isolated grounding conductors run directly back to the service equipment, minimizing the potential for noise to be introduced into the circuit. The electrical code specifies the requirements for installing isolated ground receptacles. They must be clearly identified with an orange triangle on the face of the receptacle. Fourthly, let's consider the bonding requirements for swimming pools. Swimming pools present unique electrical hazards due to the presence of water and conductive elements. The electrical code provides specific requirements for bonding all metal parts within and around swimming pools. This includes metal pool structures, metal fences, metal ladders, and metal equipment associated with the pool. The purpose of bonding these metal parts is to equalize the voltage potential, minimizing the risk of electrical shock to swimmers. The electrical code also requires the installation of ground fault circuit interrupters, GFCIs, for all electrical circuits serving swimming pools. GFCIs are designed to detect small leakage currents and quickly interrupt the circuit, preventing electrical shock. Fifthly, it's essential to understand the requirements for surge protection. Surge protection devices, SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. SPD are typically installed at the service entrance to protect the entire electrical system. The electrical code recommends the use of SPD in residential and commercial buildings. SPD diverts surge current to ground, preventing it from damaging sensitive electronic equipment. 6. Let's talk about the use of aluminum conductors. When aluminum conductors are used, special precautions must be taken to ensure proper connections. Aluminum conductors can corrode when exposed to moisture, which can lead to loose connections and overheating. The electrical code requires the use of approved connectors and termination methods for aluminum conductors. These connectors are designed to prevent corrosion and maintain a reliable electrical connection. 7th, consider the electrical code requirements for flexible metal conduit. Flexible metal conduit (FMC) is often used to protect electrical wiring in exposed locations. The electrical code specifies the requirements for grounding FMC. FMC must be grounded at both ends to provide an effective ground fault current path. Grounding can be achieved by using approved connectors that provide a direct connection to the equipment grounding conductor. 8. It's crucial to be mindful of the electrical code requirements for underground wiring. Underground wiring must be installed in accordance with specific requirements to protect it from damage. Underground wiring must be buried at a minimum depth, depending on the type of wiring and the location. The electrical code also specifies the requirements for protecting underground wiring from physical damage. This can be achieved by using conduit or other approved methods. 9th, consider the requirements for electrical boxes. Electrical boxes are used to enclose electrical connections and devices. The electrical code specifies the requirements for selecting and installing electrical boxes. Electrical boxes must be sized appropriately to accommodate the wiring and devices. They must also be securely mounted to prevent them from coming loose. 10th, let's briefly touch on electrical permits and inspections. Electrical work typically requires a permit from the local building department. The purpose of the permit is to ensure that the electrical work is performed in accordance with the electrical code. After the electrical work is completed, it must be inspected by a qualified electrical inspector. The electrical inspector will verify that the work has been performed correctly and that it meets the requirements of the electrical code. In closing, always remember that electrical safety is paramount. If you are unsure about any aspect of electrical work, it is best to consult with a qualified electrician. By following the electrical code and taking appropriate safety precautions, you can help to create a safe electrical environment for yourself and others. And with that, we conclude this explanation of electrical bonding and grounding in residential settings, specifically addressing the scenario of plastic water piping. Remember to always consult the latest edition of the electrical code and local regulations for the most up-to-date and accurate information.